F5. We did it back in chapter 7 as an example of something that's going to violate on the high side. And when we did the Lewis dot structure, we came up with a wagon wheel here. Okay, now remember, that doesn't show you shape. You're seldom going to see the wagon wheel in nature. Okay, so let's go through, and when we did it, there were no lone pairs on it. You know, we didn't have any leftovers, so it was just this. So this is straight out of chapter 7. Okay, Eddie, how many atoms around the central atom?
5.
5. Okay, Russell, how many lone pairs?
0.
0. So our number of things, Antonio?
5.
5. We must have a new shape. Let me write the name down, and then I'll show it to you. Trigonal bipyramid. Trigonal bipyramid. And since we do not have any lone pairs, we know our molecular shape is automatically going to be the same. Now, let me show you. It's going to take the kind of brass-colored jack to do this. Let me hold it up. It's going to look like that. Build it if you can. Now, if you look carefully, here are two shapes that we have used before. Watch this. That's linear. Then, in the plane, I have these three. That's the shape you've seen before, trigonal bipyramid. So we put, or pardon me, trigonal planar, I'm sorry, trigonal planar. So if we put these two together with the brassy looking center, okay, make me one. And I hold it like this, the up and the down and 3 in the plane. Okay, I see a good one there. You have 4 in the plane, so you got the wrong jack. Okay, you've got the wrong jack, Nikki, because you would have a 4th one out. Your angles are going to be that brass one. Okay, Prashant, you got it. Okay, you got it, but you got it tilted. Go. Hold it by the wrist. There you go. There you go. Okay, how are we doing?
6.
Some of you are going to fail kindergarten here. Okay. Charles, you got 4 in the plate. That's another shape coming up later. I want 3 in the plate. Good, Allison. Show him which one to use. Yes, sir. You're looking good. Are we making it? If you got 4 in the plane, you got the wrong connector. Okay, now, we have these two shapes put together, an up and a down, and a 3 in the plane. Okay, now, fantasize with me a moment. I'm going to cover this bottom one. Okay, with a little bit of imagination, could you see this top one? If it were made out of a solid piece of wood, we have ourselves a pyramid with a triangular base. Here's the point. There's a pyramid. Now, I'm going to turn it over. There's a second pyramid. So what have we got? I've got one pyramid pointing up. I've got a pyramid pointing down, and they're sharing the same base. So here's what they named it. Trigonal, because of 3 in the plane. Bi, meaning 2, like in bicycle. Bipyramid. That's why you got to analyze these words, or you'll go nuts. You got trigonal planar. You got trigonal pyramid. Now you got trigonal bipyramid. But if you'll stop and think, what do these words mean? You'll have it. Okay, so we've got trigonal bipyramid. Now there's more than one angle for the first time here. Can anybody tell me an angle? 90. Okay. Okay, I see. I hear a 90. What else did I hear? 120. Is there anything else? 180, good. Is that it, or is there anything else? That's it. Okay, now look at this, if you didn't see all that. Top to bottom, 180. Okay, now I'm going to turn mine this way for a moment. In the plane, 120. Then, top to the plane, 90. Or bottom to the plane, 90. Now you say, oh, but you said 90 is bad. But you got 5 things around you, you are going to be crowded. And so we have to accept a 90 if we're going to have these. That's why we don't see these a whole bunch. If you want to make phosphorus pentafluoride, you got to use really harsh conditions, high temp, high pressure. You could make it happen, but it's so crowded it doesn't like to happen. Okay, so trigonal bipyramid. All right, now, if these are all fluorine, 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 or all chlorines for that matter, if they're all the same, could anybody tell me, polar or non-polar? Non-polar, fantastic, because up cancels down, the 3 in the plane cancel each other. So it is non-polar. How about resonance? 0. No doubles, no triples, no resonance. Great. Okay. Now, I know it's late, but I want to do this one last thing. Before we take our break, we'll do this quickly. And if I run us over, we'll still take our 10 minutes. Okay. Name it.
Sulfur tetrafluoride.
Sulfur tetrafluoride. And we did the Lewis dot in chapter 7. And we had a leftover for the first time, leftover pair. And we know the central atom always gets a leftover. Now let's fire through here. Nina, how many atoms?
4.
4. Trent, how many lone pairs? 1. How many things here, Hina?
5.
5. If you got 5 things, the orientation is what? Trigonal. Good. Trigonal bipyramid. Okay, now here's the new part that I wanted to get in. Once you get this shape, it matters where you stick the lone pair, because not all spots are created equal. And let me see if I can convince you of this. I know you're getting tired. Okay, the up spot is the same as the down spot. Okay, but the up spot is not the same as being in a plane. There are 2 unique spots. Okay, now we got to think. We got this lone pair coming in. Where should we stick it? Okay, now, I think intuitively we probably say top or bottom. And I did too years ago. Okay, now let's put it in the top. Remember, anything less than 90 or 100 degrees is bad news. Here's my lone pair. It's the red. And somebody said stick it on the top. How many near neighbors? And when I say near neighbors, I mean less than 100 degrees. You have 3 near neighbors. If you're in the top spot, or if you're in the bottom spot. Now, let me stick it in the plane. Okay, if I put it in the plane, how many near neighbors? 2. This one and this one. So guess where it goes? In the plane. Okay, if you have, generalization, if you have a trigonal bipyramid and you have 1 lone pair, stick it in the plane. If you have 2 lone pairs, stick them in the plane. If you have 3 lone pairs, stick it in the plane. Okay, have any of you seen or heard My Fair Lady? Okay, you're probably way too young for this. There's a song in My Fair Lady, which was a stage play and a film. The rain in Spain comes namely in the plane. Okay, I always think of that song. And meaning, it always rains, you know, on the flat in Spain, in the plane. Okay, if you have a lone, I wish somebody had set this to music for me. If you have a lone pair in a trigonal bipyramid, where does it always go? In the plane. In the plane, in the plane, in the plane. Okay? Now, one last thing. Shape on, well, we'll finish this up. Shape, my God, they're so crazy. You take this off. This is what the original chemists saw. Okay, you've got to take the one off. Now we know what the orientation is, but molecular shape, take it off, turn it sideways, give it a little squeeze, because a lone pair gives it a little squeeze, and then think of a children's playground. Seesaw. Now they must have been smoking funny little cigarettes when they thought of that. But this has the weirdest name in the world. They call it a seesaw. Now, if you had asked me, and they didn't, I'd say a distorted square pyramid. Doesn't that make more sense since everything else has logical, semi-logical names?
That's a longer name.
What's,
It's a longer name.
yeah, it is a longer name. So seesaw. And like children, you know, what's the other word for seesaw? There's another word for seesaw. Teeter-totter. Thank you. Okay, if you don't see it, see this is down on the ground, little kid here, and they're going boom, 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 back and forth, seesaw. Okay, now, let's finish this one off. Bond angles, what do we have left? And will they be right on the money or less? Less than, tell me an angle you see. Less than 180. Less than what?
90.
Less than 90. Less than 120. Good deal. Polar or non-polar? Polar. Got that lone pair? Number of resonance forms? 0. Fantastic.
What is the hybrid?
That's coming at the tail end of this chapter, and don't worry about it yet.
So
Leave that last column blank for the time being. Let's take a 10-minute break.